So I want to use the formula. It's okay. I got no problem with formulas, friends. I got no problem with formula. I got no problem with technology. We will round maybe, Candace. I want to see if the result comes out to be first. Hold tight on that. You're about 3 steps ahead of me. I got no problem with technology. I got no problem with formulas. I have a problem with blind use of either. I want you to understand why any formula works before you start using it. Fair? Hope that's fair. It breaks my heart to hear somebody say, after 12 years of using it, I now know why it works. It breaks my heart. That's the first thing you learn. First of all, why you need it, and secondly, why it works. Then you're like, okay, I got it now. So anyway, average. I'm going to go ahead. Let me swing the camera so you can see what we're doing. There we go. I'm going to use the exact same thing that adding up the data and dividing by little n, yes? Add up the data, divide by little n. So adding it up, I get 142. There are 35 of them, yes? 35 individual data points, good. When we do the division, about 4? Just over 4? 4.06? Want to call it 4.1? Call it 4.1. 4.1. 4.1 what? Keys per person, right? If you think about it, unit analysis, and I will not mention this more than once or twice because I know I've tortured you guys in 105 with it. Keys, people. Keys per people. Bruce loves unit analysis, and I do too. So this is 4.1 keys per person. And if you don't remember to put the unit on there, I'm not going to get upset, obviously, because it's over and above. But that's what it means. So interpret that for me, if you would. What does 4.1 keys per person mean? It's the average, but give me, like, what does that mean on average?
On average, in Sherman's class.
If you even it out.
Yeah, started with an if.
Yeah.
If we did what? Go ahead, Linda, help me out.
Looked at all the keys and then distributed them evenly each person would have 4 keys.
It's a ridiculous example, isn't it? It's a ridiculous example. But if I had like a bin over here, if I had a bin by the door, and when you walked in, you dropped your keys into the bin, like some crazy weekend party, drop your keys in the bin, and then at the end of the weekend, I dumped all the keys back out and made 35 equal piles. Each of those piles would have 4.1 keys in them. It's kind of ridiculous, right? It's ridiculous when you think about keys. But think of it like this. When they tell you the average salary of a United States citizen, a working, voting age United States citizen, right, we shake our heads because what that means is they take all the people that make $0 and they take Bill Gates and they knock his salary down and they give his money to them so that everybody in America has the same amount of money. That by itself is an extraordinarily meaningless number. So you have to question, good, I like that look. It's like, okay, I never thought about it like that before. Good. We want to think about whenever you, on average, really on average, let's talk about that. We are talking about it right now, aren't we?
Yeah.
We are talking about it. It's the equitable, it's the equitability. If we all had the same number of keys in this room, we'd still have 142 total, but we'd all have the same number individually with no variation. Oh.
I remember some from Math 105.
You do, tell me.
Okay.
This makes me happy.
So, you pulled up a graph, and I can't remember.